A co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM.
Good evening, everybody. Welcome to York University, the Astronomy and Astrophysics program written and presented by the students, faculty, alumni, not to mention the darn good friends of York University. I'll be one of your three hosts this evening. My name is Paul Delaney, joined by that ever-ready Shatish.
Hi, everyone.
All the way from the west coast, the sunny west coast of Canada. And, of course, that diligent, hard-working graduate student, Sana.
Hi.
Hi. It's nearly the end of term, kiddo. You'll get there. Okay. Broadcasting live from the Alan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. And, of course, it's Monday night. It's therefore Astronomy Night in Canada, where the lineup is entirely Canadian, starting with ourselves, York University, on to Western world's quirks and quarks, not to mention science for the people. York University broadcasts every Monday night at 9 p.m. local Toronto time. That is now Eastern Standard Time. Yes, daylight saving disappeared yet again last weekend. Of course, that means it's Tuesday morning, 2 a.m. Universal Coordinated Time. The York University production works in concert with our online public viewing program run by the Observatory team. It runs between the hours of 9 and 10 o'clock Eastern Time here in Toronto. By all means, set your favorite web browser to observatory.info.yorku.ca and follow the links to online public viewing. You can also charge across to our YouTube channel as well, Alan I. Carswell Observatory. Unfortunately, the telescopes are preoccupied tonight, so there will not be any live views from the observatory. But there will be lots of archival images, not to mention scintillating conversation from the observatory team. Our broadcast is powered by and is in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you might have about our past shows, or if you've got suggestions for future topics, by all means, drop us a line at observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle @YorkObservatory and Facebook @Alan I. Carswell Obs. All of our programs are free, but if you would like to make a donation, hey, it's a Christmas season coming up, check out our website, observatory.info.yorku.ca. We will keep an eye on the OPV chat room for any questions, and we may even post content there. So it is now well over the first week of November, people. Okay. How has November been treating both of you?
It's cold. I love it.
Did you say it's cold?
Yeah, it's cold.
It was 18 degrees out today.
Yeah, but the past couple of days we've had it's been going down to minus 1 or 2 degrees recently.
Well, that is true. It has been chilly overnight, and of course that means nice, clear, steady evenings at the observatory. But oh gosh, during the day it's been gorgeous. I mean, really.
Yeah, I love this weather. It's great.
And long nights. I mean, we were on target tonight by 5:45 in the evening. Oh, I love November in that regard. That's for sure. And Shatish, you were saying that you haven't seen a star in Vancouver skies for about 17 months?
When I say 17 months, I was talking about the past 3 months at the most, but no, that's okay.
I was exaggerating, I admit
it. Yes, well, and thanks for exaggerating, because I was about to talk about Sana saying that, the -2 is actually cold, because I was like trying to think of think of a joke about -2 not being so cold for Toronto weather. So I guess I got paid in advance by you with the exaggeration. If that's the right way to say it. But yeah, so I haven't seen a star properly in the last 3 months on Vancouver skies, definitely. And I will try and use that reference, because some of our listeners actually might be able to relate to it. So like I said, these skies are literally like the dreamy sequence in the Roxette song, I Wish I Could Fly. I think I've placed it better this time, so people will relate to it.
They certainly will. Hey, and people out there know more about music than I do. So I mean, I still like Dean Martin, and you probably don't even know who Dean Martin is.
I absolutely do know who Dean Martin is, sir, and I wouldn't get into that on the show, of course. But Roxette was 90s, I think, and Dean Martin was probably 70s and 80s, if I'm not
60s and 50s.
60s. Okay, cool.
Yeah.
So those were the legends. So those probably are the legends still.
They are the legends. I'm impressed. You actually know some legendary music. We'll have to talk more over coffee. What? All right. Okay. Enough of the chit chat. This week in space and astronomy history, Sana, would you like to lead us off, please?
Sure. So November 11th, 1966, which is the launch of Gemini 12. A bit about the Gemini program itself, or Project Gemini was NASA's second human spaceflight program, following Project Mercury and right before the Apollo program. And the main goals for this project was essentially just to learn more about human spaceflight, to kind of bridge the gap between the knowledge that they had from Mercury and what they would need for Apollo. So mainly the things that they were focused on was developing techniques that would be needed for Apollo missions, like spacewalks and rendezvous and docking with spacecrafts in orbit. So Gemini 12 itself was the 10th and final manned mission in this project, launching, like I said, November 11th, 1966. It launched from Complex 19 at Cape Canaveral aboard a Titan II rocket. Like all of the Gemini missions, Gemini 12 had two crew members, Commander Jim Lovell and pilot Buzz Aldrin, both of whom would later fly on Apollo missions. They spent a total of about 3 days in orbit, during which they rendezvoused and docked with an Agena target vehicle, and Buzz Aldrin also completed 3 spacewalks. So when they docked with the Agena, they docked with it on November 12th, which was actually the 4th time that an American crew had docked with a spacecraft in orbit. Even though it was only the 4th time, and it's probably been done hundreds of times by now, a lot of the details of this rendezvous and docking procedure had already been more or less worked out by crews on previous missions. So to expand upon that, Lovell and Aldrin performed several maneuvers with the Agena target vehicle, including undocking and redocking again, and moving the spacecraft around. So an interesting thing that I learned about this mission was that part of the maneuvers they were doing was moving the Gemini capsule and Agena into a location that they could see an eclipse that was taking place over South America. And that was actually the first time that a crew had viewed a solar eclipse from space, which is pretty cool. But aside from that, probably the most important achievement from Gemini 12 came from what they learned during the spacewalks. So like I said, figuring out how to do spacewalks effectively was one of the main goals for this project. But even at the last mission of the project, they were still having issues figuring out how to do it effectively. Astronauts who had previously done spacewalks had become dangerously exhausted. So NASA really needed to figure out a way to do these effectively before the Apollo mission. So what they did is they implemented several new techniques to try and figure out how to make spacewalks feasible. They installed new footholds and handholds on the outside of the vehicles so Buzz Aldrin could hold himself in place more easily. They implemented scheduled rest periods for him, and they also started using underwater training before the launch or before the mission so that he would be more prepared for the things that he was going to have to be doing on his spacewalks. And their efforts did pay off because for the first time on Gemini 12, Buzz Aldrin showed that astronauts could do useful work during spacewalks without becoming exhausted like they had on previous missions. And I believe all of the new techniques to combat exhaustion are still used in training and during spacewalks today. So it was definitely an important mission in terms of being able to accomplish spacewalks in general. In fact, for this mission, Buzz Aldrin was able to set a record for the longest spacewalk ever at the time, lasting about 2.5 hours. Finally, the mission also demonstrated the use of automatically controlled reentry, which they used when they splashed down on November 15th. So happy anniversary to the launch of Gemini 12, a really successful mission.
Yeah, we think about spacewalks today, and nobody gives it a second thought. The astronauts go outside of the International Space Station for 6, 7, maybe 8 hours at a time. And, you know, they go out and they reposition solar panels. They disconnect and reconnect all sorts of power sources. They replace big pieces of equipment and so on and so forth. It is now routine. But back 45 years ago, and that's what we are talking, 55 years ago, not 45 years ago, 55 years ago, it was anything but routine, as you just described, Sana. It was a chore to go outside. And here we've got Buzz Aldrin, famous, of course, for the Apollo 11, basically showing how it's done. It took almost every single Gemini mission to be able to achieve this feat. And basically, if they hadn't have sorted it out, it would have put them behind with respect to the Apollo missions. So, yes, it was incredibly pivotal as far as our ability to work in space is concerned. And all of what Aldrin did back then, 55 years ago, is still in play today.
Yeah, I was... Oh, sorry, go ahead.
No, well, I shouldn't have interrupted, but I actually have two questions instead of one now, and I should have read about them. I'll just shoot the questions and then I'll wait for everyone else to talk. Watching the solar eclipse, from space, I'm pretty sure that's really interesting and a really difficult task at the same time. And B, did they actually have underwater training in space?
No, the underwater training, answering your second question first, is basically a big swimming pool at the NASA Space Flight Center in Houston. So this is where they would start putting a mock-up of whatever the equipment is that the astronaut is going to work upon, and then they submerge the astronaut in the spacesuit, because obviously it's watertight as well as airtight, and because being in the water gives you almost the feeling of neutral buoyancy. So they balance the weight and the buoyancy so that as the astronaut is moving around the target in the swimming pool, submerged, it is an excellent simulation of the weightless environment. And so it prepares them for whatever the task is that in space is required of them during the spacewalk.
Okay, well,
it's a big swimming pool. I mean, it's huge. It currently holds a mock-up of the International Space Station.
Oh, man.
Yeah, it's big. It really is. But anyway, what were you going to say, Sana?
I was just going to say that I thought it was interesting that this was the first time that underwater training was used.
Great minds are thinking alike there. Yeah, I mean, it took, it took 3 or 4 years to realize that this would be a good thing to do because, I mean, first American in space was John Glenn in February of 1962, and here we are in November of 1966. So there wasn't a whole lot of time delay, but it has been used continuously ever since.
Mm-hmm.
Yeah, absolutely.
Yeah, another interesting thing about this solar eclipse that I thought I would mention is that Buzz Aldrin actually saw 2 solar eclipses from space. He's flown in space twice, once on Gemini 12 and once on Apollo 11. And on Apollo 11, they can kind of manufacture their own solar eclipses because they travel behind the moon. So both of his flights, he saw a total solar eclipse because they could manufacture them on Apollo 11. And apparently the views of the corona were amazing from Apollo 11.
Now I'm finally jealous.
Well, yeah, absolutely. Yeah, that's also cheating. I mean, having your own moon at your disposal, so to speak, with your spacecraft. I mean, really. But that's a great stat. I mean, I doubt there are any other astronauts who can say that they have been witness to 2 solar eclipses.
Mm-hmm.
Very cool. Very cool. Hats off to Gemini 12. Well, staying with a spaceflight theme for a moment, November 12th, so the end of the week, 1981, saw the flight of STS-2, the second space shuttle flight. So, Sana has just mentioned Gemini. Of course, preceding Gemini was Mercury. Following Gemini was Apollo. You could sort of say Skylab followed that because it certainly did. That would make the shuttle system the 5th of the human spaceflight series, if you will, that was generated by NASA. The space shuttle was meant to be the replacement, the follow-up to Apollo. They cut the Apollo missions short in 1972. They were meant to fly up to Apollo 20, and they only flew up to Apollo 17. The aim of the exercise, purportedly back then, was, okay, let's transition into accessing low Earth orbit more frequently and theoretically cheaper. That was the hallmark of the shuttle. It was going to be a reusable system that could fly into and out of Earth orbit, potentially, and believe it or not, they actually thought this was going to happen in the 70s. They would fly a shuttle into orbit once a week. And being reusable and so on and so forth, everything would be that much cheaper because you'd be amortizing the shuttle's cost over a large number of flights. And as I say, access to Earth orbit would be really, really cheap and easy. Yeah, well, we all know how that worked out. Not quite so cheap or easy to do. But the Skylab missions that I mentioned were designed to be the first orbiting space station from NASA, and it was. And during 1973, Skylab saw 3 distinct crews fly on board. Unfortunately, Skylab wasn't very high, and it was going to deorbit a little earlier than planned. And so the expectation was that this fledgling space shuttle system was going to fly up and save Skylab, boost it. STS-2 was meant to be that mission. Unfortunately, Skylab landed in Western Australia in July of 1979, and as I mentioned, STS-2 did not fly until November 12, 1981. Sort of missed by about 2.5 years. Very sad. And in a way, that sort of was the stamp of the shuttle series. Running late, running over budget, and a glorified truck, a nice-looking truck, that flew into and out of Earth orbit. STS-2 had 2 astronauts on board, Joe Engel and Richard Truly. They were both rookies. They flew into orbit carrying a variety of equipment for testing purposes. Remember, this is only the second shuttle mission. One of the most important pieces of equipment on board, however, was the Canadarm. This was the first flight of Canada's contribution to the shuttle program, the famed Canadarm. And every shuttle ended up carrying a Canadarm. The International Space Station carries a Canadarm, and Lunar Gateway will carry a Canadarm. You're getting a theme here. There's a bit of a trend. At any rate, the whole mission was delightfully successful, although it was cut short from its intended 4 or 5 day mission to only 2. There were 3 on board what they called auxiliary power units, APUs, which were designed to generate electricity for all of the systems on board the space shuttle. They only needed 1 APU to completely run all of the systems on board the space shuttle. By the way, the shuttle was Columbia. Quick mental blank there. But the flight regulation said that if you had only 2 viable APUs in orbit, that is to say the third one had failed for whatever reason, then you basically had to come home as quickly as you could. And they made it to orbit, and one of the 3 APUs failed. And so instead of a 4 or 5 day mission, they only flew 2 days. But it was a completely successful mission. All the instrumentation that they took on board worked fine. Canadarm stretched its arm for the first time. That all worked really good. And interestingly enough, it was also the last time that the external fuel tank of the space transportation system, the STS system, looked white. Up until that point in time, STS-1 and STS-2, the external fuel tank was painted. NASA realized that there was about 270 kilograms of paint on the external fuel tank. And of course, the more weight you're carrying, the more fuel you need to use, or conversely, you don't get as high in orbit as you would like. And so NASA made the decision after STS-2 to no longer paint the external fuel tank. And so for the next 133 missions, the external fuel tank was that burnt orange, which I'm sure both of you will remember. Interesting speculation is that, gosh, if we had kept the paint on, maybe we wouldn't have lost Columbia in 2003. That is to say, the paint may have subdued the amount of foam shedding that the external fuel tank was subjected to during launch. And of course, it was that that foam, ice foam, that punctured the left wing of Space Shuttle Columbia. At any rate, anniversary STS-2, November 12th, 1981. I always thought that the external fuel tank looking white looked pretty spectacular. I was never a big fan of the orange.
It's kind of crazy that the paint weighs that much.
It was a big tank.
Yeah. I know these things are huge, but I think sometimes I forget how huge they are because that really shocked me, that much paint.
Well, you obviously haven't carried 4 liters of paint often enough to know how heavy paint really can be and how far a 4-liter can doesn't go as far as your walls are concerned. But yeah, STS-1 and STS-2. So if you ever are watching Space Shuttle replays of launches and you see a white tank, you can impress all of your friends. It's got to be STS-1 or STS-2.
Oh man, okay. I just looked up a picture of it. That looks so weird.
I don't know about weird, but yeah.
Well, I'm used to the orange one. Like, it looks good, but it looks weird because I'm used to the orange.
That's right. You saw it 133 times as orange, so I can understand that. But to me, it looks sharp to have it white. But as I said, 270 odd kilograms of paint, and NASA said, "Oh, forget that." I mean, and they did. Satish, you have a variety of birthday shout-outs, I believe.
Yes, that's like promoting my new brand of radio astronomy.
Very good. You're the historian of the crowd.
Historian of the crowd, of course. And so it's not the variety comes from the date itself. And this is November 8th, which is, as of today, also the same day. Surprise, surprise. We would talk about 3 birthdays or 3 birthday shout-outs. To begin with, 1656, Edmund Halley, which I'm hoping is not really an unknown name for any of us. He was an English astronomer, geophysicist, mathematician, meteorologist, and physicist. I'm not sure which one comes first, but he was a bucket full of, skill sets. Let's just say that. He was the second astronomer royal, I think that's how it's said, after John Flamsteed, who, well, actually may become a story for another day. He's known for his observations on the southern celestial hemisphere. Also, the transit of Mercury across the sun, those being the very first of their kind, I think. And then the competition of the periodicity of the Halley's Comet, again, surprise, surprise, which was named after him, and the conditions of terrestrial magnetism. He is also credited with having discovered the proper motion of fixed stars. So happy birthday number 1 to Edmund Halley. Happy birthday number 2 for Riash Seddon. I'm hoping that's the right way to say it. She was born in 1947, a retired NASA astronaut as of today, and a physician, not a physicist, a physician. She was one of the first group of astronauts to include women. She flew 3 space shuttle flights and was a mission specialist for STS-51D, STS-40, and served as a payload commander for STS-58. And as I keep saying, STS is one of those missions we never talk about specifically, but there are loads of them. She was also the first ever human to go on an unscheduled spacewalk, which we just spoke about a lot already, but not the unscheduled ones. She had to go to activate the satellite payload Anik-C or Anik-C, and it is mentioned in the Wikipedia page that she even used a bone saw and her surgical skills to make repair tools for the satellite. So that's like, this is like a double birthday shout out for her because this is something of a space trivia, which I think generations will remember as long as they exist. The third birthday shout out would be for Dale Gardner. He was born in 1948, just a year after our second birthday shout out. He was a NASA astronaut and a naval flight officer who flew 2 space shuttle missions during the mid 1980s. I think both of them again, those aren't STS missions. He was a fellow of the American Astronautical Society and the recipient of many medals, including the NASA Spaceflight Medal in 1983 and 84. There's also a bridge known as the Dale Gardner Memorial Veterans. The Dale Gardner Memorial Veterans Bridge, which connects the Savannah, Illinois, and Cibola in Iowa, those regions over the Mississippi River. So kudos to them, happy birthday to them, and I am done for this part.
Of course, arguably the most famous of the three, and not being disingenuous to the remaining two, but Edmund Halley was a significant contributor to science back there in the 17th century. I would say that either his astronomical prowess or his physicist activities would be his main claim to fame, but he was a bit of a jack of all trades, so as to speak, because a lot of scientists were in the 17th century. Most famous, arguably, for his determination of Halley's Comet being a periodic comet. Unfortunately, he made the prediction, but died a few years prior to the actual return. Always struck me as sad that he never actually lived long enough to see the accuracy of his predictions. But every time Halley's Comet comes back, it's 76-year orbital period, we always think back, well, most of us think back to the 17th century and the works of Edmund Halley.
Pretty true. So it's also mentioned that he was sort of a good influence on Isaac Newton and helped publish his first book,
Principia.
Principia, I think, yeah.
Quite true, quite true. In fact, there are many good stories that suggest that Edmund was more than a good friend, but was something of a good conscience to Isaac. Isaac Newton apparently was a bit of a disreputable individual on occasions. Brilliant, eccentric, but perhaps lacked in a few social graces, shall we say? But I don't know. I wasn't around 400 years ago. I'm not going to preach.
Historian.
That's true. And I will go and look up the excitement around Annex C. I didn't know that a bone saw was used to help repair the satellite. I will definitely go and chase that one down.
Don't sue me. That's Wikipedia. I mentioned that. So.
That's okay. Probably is correct. Probably correct.
Okay.
Okie dokie. Sana, I think you want to take us out to a comet.
Yes, November 12th, 2014, which is the lander Philae lands on a comet for the first time. So the Philae lander was part of the Rosetta mission, which was run by ESA to Comet 67P. I'm not even going to try and pronounce the second part of that name.
Churyumov Gasimarenko? Come on, really?
Yeah.
Keep going.
Yeah, I won't be able to pronounce that. But anyways, there were two components to the Rosetta mission. First of all was the orbiter Rosetta, and then the Philae lander. The pair launched in March 2004 and then were placed into orbit around 67P in September 2014, becoming the first spacecraft to orbit a comet. Then a month later, on November 12th, the Philae lander was released from Rosetta and began a 7-hour journey to the surface of the comet. Philae was originally planned to land at a site that was named Agilica. However, the spacecraft had several issues with its landing system that prevented it from making the landing that was intended. And instead of just
sticking the landing.
Yeah, instead of sticking the landing at Agilica, it ended up bouncing 3 times and then finally coming to rest about 1 kilometer away from the intended landing site. And keep in mind, 67P itself is only like 4 kilometers across, so it did move quite far away from its intended spot. Mission controllers actually knew about one of these issues before landing. They found an issue with Philae's active descent system thruster, which was designed to prevent the spacecraft from bouncing. But they decided to go ahead with the landing anyways because Philae had 2 other systems in place to do the same thing, essentially. So they figured that at least one of those systems would work as planned and the landing would be fine, because that seems like it would make sense, like one of the 3 systems would work. But they were wrong, and all 3 systems failed. It turns out that thruster that they knew about originally didn't fire because of an issue with a seal. Then the other 2 systems that it had were harpoons and ice screws. The harpoons didn't fire because of an electrical problem with the spacecraft, and then the surface was too hard for the ice screws to penetrate. So when it impacted its intended landing site, there was nothing to prevent the spacecraft from bouncing, and it bounced 3 times, finally coming to rest in a dark cave-like area about 2 hours after that initial impact. The region that it landed in finally is called Abydos. Well, because of its location, it wasn't able to get any sunlight to charge its batteries, and its primary battery died a couple days after landing on November 15th, at which point it went into hibernation. Contact with the lander was reestablished in June of 2015 because its solar panels were able to receive some sunlight. It ended up sending several bursts of data back to Rosetta, which then transmitted them back to Earth over the span of a couple weeks. But after that, contact was lost with the spacecraft and was never reestablished. Well, despite the issues with the landing and losing contact with the spacecraft, this mission was very successful. So not only was Philae the first mission to land on a comet, but it was able to gather a lot of data that was very useful to future comet missions. And it also completed 80% of its planned science. So some of the science that came out of this mission was that Philae took data on 67P's interior, its surface, and then the environment surrounding the comet. So mainly the gas, plasma, and dust that surrounded the surface. Part of this is that it discovered that the surface of comets are fluffier than froth on a cappuccino, as one of the scientists on the team put it. It also found several different chemicals on the surface of 67P. So it found water vapor, molecular nitrogen, molecular oxygen, and then it also found phosphorus and the amino acid glycine, which are both important for life. So there was definitely a lot of really good groundbreaking science that came out of this mission. And not to mention it took really awesome pictures because comets are very pretty. So
Rosetta and Philae, whichever way you want to cut it, were stupendously successful.
yeah.
I mean, Rosetta chased down the comet over 9 years or thereabouts. Not a bad feat by itself. Rosetta hung out with Comet CG for the better part of 2 years. Pretty darn good, especially given the fact that the comet was throwing all sorts of stuff at Rosetta as it got closer to the sun. And then Philae, despite its bouncy across the surface, still did, as you say, produced and completed 80% of its science. So, yeah, it was a spectacular mission. Who would have thought all 3 landing mechanisms would fail? I mean, that's it's almost unbelievable. But it happens. It was a challenging mission, and unfortunately, we just didn't stick the landing. And, you could have got so much more if we had, but nobody is upset with what we did get from this mission. Comets are wonderful time capsules. They talk to us about the earliest moments in the solar system, the primordial soup of the solar system, so as to speak. And by and large, they don't change with time. They shed, but they don't change. So, yes, these sort of missions will continue, we have no doubt, but Philae and Rosetta, they blazed away there. Very good stuff.
It's also pretty remarkable to me that it bounced 3 times and the spacecraft still worked.
Well, yeah, that's true. I guess it's a great example of momentum. There was nothing to hold it to the surface, and so it just performed a little bit of Newtonian mechanics there. They built it well.
Yeah.
I mean, it slides in against the rock face and keeps on ticking. So, yeah, very, very good effort from the spacecraft.
Rugged is the word.
Rugged is the word. Yep, that sums it up very well. That's for sure. No complaints there. No complaints at all. I'd like to take you back to 1572. Let's slide back in history to when Tycho Brahe, imagine you're wandering around the streets of, well, it doesn't matter where you're wandering, but the streets don't have much in the way of light pollution. The stars are sprinkled above you. It's nice and dark. And you're looking towards the constellation of Cassiopeia. Yes, indeed. And you're sitting there going, just a minute, there is an extra star in Cassiopeia. Now, I know in Vancouver you're not going to see that. You might have trouble even doing it in Toronto. But under the clear, pristine skies that Tycho Brahe was under in 1572, he immediately, as did many other astronomers from around the world, immediately identified the fact that there was a guest star, there was a new star in the constellation of Cassiopeia. There's a little bit of debate about when the first observation was. Some put it as early as November 2, others put it as late as November 11. So I'm just going to say in early November, Tycho Brahe and many others noticed the fact that there was a new star in the constellation of Cassiopeia. This was a big deal, because, of course, the sky wasn't meant to change. Or if it did change, it wasn't the sky's fault. It was something that was local in the Earth's atmosphere. Because this guest star, which reached maximum brightness on or about November 16th, bright as Venus. Can you imagine? Venus in Cassiopeia. Wow, be a great sight. So because so many observers were observing this, there were observations from widely differing locations. And therefore, knowing the baseline from the two observers' positions, parallax can be used to get an estimate of the distance to the object in question. It was apparent to Tycho Brahe and others, but Brahe was the one who systematically made these observations and then published them in 1573. It was apparent that this guest star was not local. We're not talking about somewhere between here and the moon, somewhere between here and the top of the Earth's atmosphere. The parallax that was basically not really measurable suggested that this guest star was a long way away, which, of course, we now know it was. It was a long way away. But at that point in time, these transient events, including things like comets, were all thought to be, well, part of the Earth's atmosphere, some sort of atmospheric phenomena, because the distance scales of the universe were not well understood at this point in time. And so it was a really important set of observations to conclude that this new guest star in Cassiopeia in November of 1572 was not local. It became known as supernova 1572 because, in fact, it is a supernova. But it was the methodical observations of Tycho Brahe that really set the stage with respect to the scale of the universe being sorted in the 17th century. Brahe, in fact, was known for his exquisite observations, his accuracy of stellar positions, particularly planetary positions, is what allowed people like Johannes Kepler, some 30 years later, to conclude the laws of planetary motion, and in particular, that we lived in a heliocentric solar system, with the planets moving around the sun in elliptical paths. This was the legacy of Tycho Brahe. Wonderful observations, including the supernova of 1572, first seen in early November.
Sorry, go ahead.
No. I was about to say, because we are rambling a little bit tonight, and myself included here, Satish, I'm going to ask you to move us along here and finish off this week in space and astronomy history.
Absolutely. So quickly, so November 9, two different years. 1967, Apollo 4. This was the first and uncrewed flight in the Apollo program. Some know it as the AS-501, which is an association with the first test of the Saturn V launch vehicle. That was the fire vehicle or the rocket that would soon carry the first humans to space, actually to the moon. And then the Apollo 4 also was the first to be launched from the Kennedy Space Center in Florida. And also the Launch Complex 39, which boasts of facilities built especially for the Saturn V rocket. It was also another first for NASA as an all-up test, which means all rocket stages and spacecraft were fully functional on the initial flight. And when we also mentioned the delay in its launch date, but it was actually a lesson learned the hard way and an unfortunate way from the happenings of the Apollo 1 fire. So I really can't call it a birthday shout out as such, but that was one special event And then 2005, on the same date, that's November 9, Venus Express was launched as the first space exploration mission of the European Space Agency. I'm presuming it was just formed a few years before that. It took a few months to reach the fiery planet and was aimed at collecting data of the Venusian atmosphere. The mission is said to have contributed a great deal to our understanding of climate change on Earth. Perhaps the reason why we are now so woke all of a sudden, especially after the conclusion of the mission in December 2014. The mission's initial design drew parallels from the Mars Express mission, using notably some spare instruments developed for the Rosetta spacecraft. And during the mission, the detection of the hydroxyl molecule, which is the molecule OH in the Venusian atmosphere, and the existence of a huge atmospheric vortex at the south pole of the planet are considered to be one of the most important findings or discoveries. That's me.
Venus Express and Mars Express, two significant contributions from the European Space Agency as far as planetary exploration is concerned. Getting to Venus has always been a little bit of a challenge, and they did it. They the first time, they nailed the mission in their very first time, and it ran for nearly 10 years, as you said, 2005 to 2014. Not a bad way to debut their expertise in the inner solar system. So, definitely a tip of the hat to the European Space Agency. And yes, Apollo 4, back a long time ago. But given the parallel that you've just drawn, the Artemis 1 mission, due to be launched in February, same thing. They're just finished stacking all of the individual components. It's a full up test. They're going to launch it to the moon and see how it behaves. Exactly like what Apollo 4 did, although Apollo 4 did not go to the moon. They were just quite happy to get it to Earth orbit. So similar parallels. NASA hasn't changed its pattern of testing, and why not? I mean, it was a successful Apollo series, so they're following many of the parallels for Artemis.
By the way, I misspoke. The European Space Agency wasn't formed just a few years ago. It had been 3 decades before they did this.
So. I wasn't certain of that, so I okay, small little faux pas. Folks, you're listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the Alan I. Carswell Observatory here at York University in Toronto, Ontario, Canada. Shatish, Sana, myself, Paul, keeping you company this evening. By all means, point your favorite web browser to observatory.info.yorku.ca. Follow the links to OPV, online public viewing, where the team is transmitting some archival images and, of course, chit-chatting. Sana, I think we've got some action in the sky in the very near future.
Yes, the Leonid meteor shower peak is coming up. It's actually supposed to peak next week on the 17th, but next week it coincides with the full moon, which makes it hard to observe meteor showers. So if you're
sad, sorry.
Well, if you're trying to observe the Leonids this year, your best bet is to do that this week. This weekend coming up is good. So Friday, Saturday, Sunday, because the moon is setting earlier in the night, which means you have early midnight and early morning to observe the meteor shower. This also works out well because the radiant point for the Leonids is in the constellation Leo, as the name suggests, which has its highest point in the sky closest to sunrise. And that's when you want to observe them, when the radiant point is high up. So it works out really well observing the Leonids this week. And so, if you want to observe them, get as far away from light pollution as you can early in the morning. No telescopes or other optical aids needed.
And probably not blankets either at the moment, but I certainly would suggest that you wear a good thick coat because it does get a little chilly overnight still.
Yeah.
A slightly more imminent event is the splashdown of SpaceX's Dragon 2 Crew 2 mission. They are in final approach. Their deorbit burn has just occurred, or at least it should have. I'm not certain that it has, but I'm sure it has. Touchdown, splashdown just off Pensacola in Florida in about 40 minutes, 10:33. So please pop over there after we finish with York Universe. And on this coming Wednesday, of course, it's our Teletube presentation, 7:30 in the evening. It's another one of our graduate researchers from York University talking about their research. By all means, pop across to YouTube, Alan I. Carswell Observatory's YouTube at 7:30 and catch all of the interesting bits and pieces up for discussion. Okay, Sana, I believe that try and pronounce that right. The Decade Survey for Astronomy has come out. Do you want to give us the highlights?
Yes. So for those of you who have never heard of a decadal survey, as I had not until very recently, it's a survey that the National Academies of Science, Engineering, and Medicine conduct every 10 years. And pretty much what it does is they review like a bunch of stuff in astronomy to figure out what the highest priority research activities are. And then based off of what they find, they kind of guide the direction of astronomy in the United States by recommending what research projects and activities U.S. agencies should fund. These are fairly important surveys. They're very influential because funding agencies do tend to listen to what they have to say. They don't do everything that the survey committee recommends because it would cost way too much money, unfortunately. But the top recommendations generally do end up happening. So major observatories like Hubble or James Webb were top recommendations in decadal surveys in the past, and they happened. So at least something that's mentioned in this survey is probably going to happen in the next decade. Their most recent one was just released late last week, called Pathways to Discovery in Astronomy and Astrophysics for the 2020s, which I'm just going to call Astro 2020 because that's a very long name. They have some really amazing recommendations for astronomy in the next decade. So first of all, they identified 3 priority scientific areas for funding. First of all is to identify and characterize Earth-like and potentially habitable exoplanets. Second is to investigate black holes and neutron stars. And the third is to probe the evolution of the early universe and the formation and evolution of galaxies. So based off of that, they then recommend several things about how to accomplish this kind of science. So first of all, they have some recommendations in terms of ground-based astronomy. Their top recommendation in this category is for the U.S. National Science Foundation to fund 2 major ground-based observatories, the 24.5-meter Giant Magellan Telescope and the 30-meter telescope. The benefit of both of these telescopes getting funding is that it would give U.S. astronomers coverage of both the northern and southern skies, which would be a great perk for them. In terms of ground-based astronomy, it also recommends upgrades to the Very Large Array radio telescopes and the construction of a new cosmology experiment to study the cosmic microwave background. They also have a couple recommendations in terms of space-based astronomy missions. So first of all, it recommends that NASA fund more mid-sized space missions and launch not 1, but 3 flagship observatories. 2 of those flagship observatories are recommended to be an X-ray and a far-infrared telescope that will each cost about $3 to $5 billion. And then its top recommendation is awesome. It's the launch of a true successor to the Hubble Space Telescope that would have coverage in ultraviolet, optical, and near-infrared light, but it would have a primary mirror with a diameter of at least 6 meters. So this is basically a James Webb-sized telescope, but with a lot more wavelength coverage than James Webb. It would be a really big project, cost about $11 billion, and launch in the 2040s. So a crazy telescope. This thing will be awesome.
Both of you will almost be retired, but that's okay.
Yeah. Well, especially given their last recommendation, because it's already going to cost so much money and take so long to complete, they recommend changing how mission planning is done at NASA and other U.S. agencies. They noted that there has been a general lack of order when it comes to planning in this field. James Webb Space Telescope is a great example of that. So the survey committee recommended that NASA should establish a new program called the Great Observatory's Mission and Technology Maturation Program. Basically, what this would do is it would change the way that major projects are planned and developed at NASA based off of what has been learned from past missions so that it's more organized and you avoid like massive delays and cost overruns, again, like what happened with James Webb. So included in this recommendation is that NASA should have an independent review done of the feasibility of that Hubble successor mission, just to make sure that it actually launches more or less on schedule and more or less on budget. And finally, the last recommendation I'll talk about from this survey is that for the first time in any of these decadal surveys, Astro 2020 laid out recommendations for dealing with systemic racism and sexism in the field, including, and I'm quoting from the decadal survey here, a new model for respectful collaborative decision-making in partnership with Indigenous and other local communities. So lots of great stuff in Astro 2020. I am definitely looking forward to these missions, but we're probably going to have to wait until 2024 for any of the funding and stuff for this to come through, because COVID-related issues delayed the release of the survey, and funding agencies have already planned budgets for up to 2023 by now. So we'll have to wait a few years, but definitely pretty exciting.
Just as well that you'll be able to work with the James Webb Telescope to while away your hours of free time. All of this does sound absolutely fabulous. I mean, whenever these decadal surveys come out, your mouth begins to salivate, but you do have to temper your enthusiasm because it does take a long time. All of the projects that you cited there, Sana, of course, are going to be at the least, 2030 before they fire up, or that would be my expectation. I mean, the 30-meter telescope and so on, that's already being built. The 24.5-meter Magellan, again, I believe is already underway. Completing them and building the instrumentation and so on, you'll see them in all likelihood this decade, but almost everything else has got a timeline that is certainly measured in decades. Mm-hmm. I have no criticism of that because they are so expensive. They're going to have to take that level of time for the funding to be made available. And of course, you want to plan them carefully and so on and so forth. So it's just a fact of life. Space missions in particular take a long time, but you don't build 30-meter observatories on the ground overnight either. Mm-hmm. Most of the current really big telescopes have been under active review already for at least 10 years, and none of them are going to be ready before 2024. So, even on the ground, 14, 15 years worth of lead time is necessary. But exciting to say the least, that's for sure.
I think I'd like to take an amateur's dig at this, this portion of a decadal survey. So, for example, I did an article on the LSST as part of the Astrotech course, and I can totally appreciate how 20 years literally don't mean anything for the project's success. It's still a bearable time. And I'm trying to say, Professor, the way 1 meter came up at York, I think even that took at least, 5 years or 3 years for you to manage
between 2 and 3. Between 2 and 3, depends how you want to do the arithmetic. But even a 1 meter telescope, getting the funding in place, dotting the I's, crossing the T's, none of that happens as quickly as you would like them to be. We're in the process of putting together new domes for the observatory on campus, and if we are fortunate from beginning to end, it's only going to be a year and change. And this is for equipment that already exists, that they relatively mass produce. So, these projects do take their time. But I counsel patience, because the end result, look at Hubble, is really well worth it. And after we've all watched the successful launch of Webb next month and see it completely unfurl in the following month, we'll all go, it was all well worth the wait. Satish, our last story.
I'll try and speed read this.
Oh,
This is
no. You've got lots of time. Take it easy.
Okay, well, thanks for setting me right. Okay, so let me talk slowly now. So Juno, which we are all aware of, it's been peering deep into Jupiter's colorful belts and zones. Uh, the pattern that extends deep below the clouds is what this research is, or this news is all about. Juno completed a 5-year cruise to Jupiter, arriving on the 5th of July, 2016. And the University of Leicester, pronouncing it right, study of the data captured in orbit around Jupiter has revealed new insights into what's happening deep beneath the gas giant's distinctive and colorful bands. The data from the microwave radiometer carried by Juno shows that Jupiter's band pattern extends deep below the clouds, which I've just repeated actually. And then the appearance of the belts and zones inverts near the base of the water clouds, which is something interesting, which at least I am thrilled about. The microwave light allows planetary scientists to gaze deep beneath the colorful clouds that we see on the surface of Jupiter and to understand the weather and climate in the warmer, darker, deeper layers. Dr. Lee Fletcher, an associate professor at the University of Leicester, and participating scientist for the Juno mission, who's also the author of the study. They tell us that the study has shown those colorful bands are just tip of the iceberg, and that the mid-latitude bands not only extend deep, but they seem to change their nature the further you go down. So at altitudes shallower than, let's say, 5 bars of pressure, or around 5 times the average atmospheric pressure on Earth, the planet's belts shine brightly in microwave, whereas the zones are dark. But everything changes at higher pressures, at altitude, deeper than 10 bars. That gives the scientists a glimpse of an unexpected reversal in meteorology and circulation. The planetary scientists call this these light whitish bands zones, and the darker reddish ones belt. The winds that circulate on the planetary level in Jupiter or on Jupiter, they do so in opposite directions and east and west on the edges of these colorful stripes. So a key question is whether this structure is confined to the planet's cloud tops or if the belts and zones persist with increasing depth. And an investigation of this phenomenon is one of the primary objectives of NASA's Juno mission. And the spacecraft carries a specially designed microwave radiometer to measure emission from deep within the solar system's largest planet, as we call it. So the microwave radiometer operates in 6 wavelength channels ranging from 1.4 centimeter to 50 centimeter. And that enables Juno to probe the atmosphere at pressures starting, let's say, near 0.6 bars, which is at the top of the atmosphere, to pressures exceeding 100 bars, which is approximately 250 kilometers deep below the surface.
Juno has quietly been going about its job of unraveling the interior of Jupiter. It doesn't get a lot of press, shall I say, but as you've just sort of pointed out, it's really sort of quietly digging deeply beneath the surface. They've mapped out the gravitational interior. They've concluded that there's probably not a solid core at the center of the planet, that it's more likely a gradation of denser material out into sort of the hydrogen and helium metallic layers that are buried deep within the planet. So it's an unusual structure for the gas giant. And here we are trying to probe the wind structures that are equally unusual. So, whichever way you want to cut it, Juno has done a really exceptional job of probing the largest planet in our solar system. Okay, folks, we've reached the top of the hour. You've been listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the Alan I. Carswell Observatory here at York University in Toronto, Ontario, Canada. Satish, Sana, myself, Paul, keeping you company this evening, wandering around low Earth orbit, charging off to supernovae, not to mention Jupiter on the way. By all means, please stay tuned to AFM, Astronomy Night in Canada, because, of course, it's Monday night. It's therefore completely Canadian. We've got Quirks and Quarks, Science for the People, not to mention Western Worlds. We'll see you all again next week. Good night.
Good night.